Hello, my name is Abby Sicklesteel, and today I will be talking to you about the multi-machine assignment problem in CPLEX and how I modified it and made a heuristic for it as well. The original problem description says that there are multiple machines and multiple jobs that need to get done. This program will solve for which machines will do which job. It takes into consideration when it can be started and when it needs to be done by. This program is also trying to minimize the cost of the process. I've tried to add to this to make it more complex, and here's the new problem description. There are multiple machines and multiple jobs that need to get done. Each machine has a different production rate per hour, and there is a quota for each job at the end of the working day. A company has 5 plants in 5 different states that can do this production, but they aren't sure which plant to consider. Each plant has these machines, but the machines have different production rates. This program will solve for which machines will do which jobs. It takes into consideration when it can start, when it needs to be done by, the quota, and the production rate. This program is also trying to minimize the cost of the process because the company has to pay their employees, but they are facing some cutbacks, so they can only pay their employees so much. On the left is the original .mod file, and on the right are the modified .mod files. Everything that is boxed in pink has been added to the code. I have added the number of work hours, the states that the plants are in, the employee costs at each plant, the production rate for each machine at each plant, the overall employee costs, the overall total cost, and the constraints for each thing added. On the left is the original .dat file, and on the right is the modified .dat file. Everything boxed in pink is what I've added. This is the heuristic that I have developed for the original problem. I did this so I could get a grasp on the concept as well as the original CPLEX code. The heuristic loops through itself 50 times. It starts at machine 1, job 1, and randomly picks either a 0 or a 1. From there, it will start the production time. If the start time is more than the time that the job is due to be done by, then a 0 is placed on that spot. If there is a 0, then the other spot must be a 1, because there are only 2 machines it can be produced on. Then it calculates the total cost and stores it. Next, it will check the heuristic and see if it is within the constraints that I've set for it, and then it will go through one final check. Now I will demonstrate this in Excel. Since it is a heuristic, I will sometimes not get the correct answer, so I have to run it a few times. This is the answer that we get in CPLEX. So the heuristic works, but you have to run it a few times in order to get the same answer as it does in CPLEX. This is the heuristic for the modified problem. It runs through the first part and then it will run through the constraints to solve for which plant will produce the products and the overall total cost. First, we initialize the array employee plant, which solves for which plant will be the one producing the products. Then we will run the heuristic and clear the employee plant cells from the run before. While the sum of the cells is greater than 1 or equal to 0, it will run through this for loop, which randomly picks either a 0 or a 1 for the employee plant array. If that current cell multiplied by the employee cost array is greater than 5, then that plant is no longer an option since the plant is facing cutbacks. Next, it will store the objective function in the employee plant array. After running through the for loop, it will output the minimum objective value in the corresponding employee plant array. Now I will demonstrate this in Excel. This one will take a while to get the right answer, however. As you can see, the heuristic works and it got the correct plant for production, but there is probably something wrong in my calculation of the objective function. If I had more time, I would look into this and solve it. I have learned from this project that trying to code constraint programming into a heuristic is very difficult to do. I thought that I could easily get this done in a few days, but I was struggling and I need to work on my time management. If I had more time, I would generalize the heuristic so that it can work with other datasets, but that is something for further research. Thank you for watching.